Hey everyone, it is this side. Hope you are doing good. So let's start with the question. So the question is implement stack using queue. Okay. So basically you have given a stack. Basically you have to implement a stack implementation using the queue. So as you know, stack is a last in first out stack. So it's a LIFO structure follow. So what you have to do, you have to instead of using stack, you have to use two queues. Okay. The implemented stack should support all the functionality of a normal stack like push, top, pop, and empty. So push basically means you have to insert the element in the stack. Pop basically means removes the top element from the stack, and top will return the top element from the stack. It's not removing, it's just giving the peak element of that. Empty basically returns true or false whether the stack is empty or not. Okay, you must. Okay, so let's see how we can approach this question. Okay, so let's understand with an example. Let's assume we have a stack. Okay, so first step is to create a stack. We will create a stack, then we have to push the element. So let's say we push this element in a stack. Okay, so we push this one. Now after this we again push the element, so we'll push this second. Now what we have to return? We have to return top element. Okay, so if you can see top, it is 2, so we just give the output as 2. After this we have operation of pop, so we have to remove this and print it, so we'll print 2 also. Then there is a function for empty, so we'll check whether stack is empty or not. You can see stack is not empty, so we just return false for this case. Okay, so now what you have to do, instead of stack you have to use two queues basically. Okay, so this is one queue, this is second queue, q1, q2. As you know, stack follow LIFO structure. Basically whoever comes last will be the first who will remove from it. Okay, and q is just opposite of that. Q is FIFO. So whoever come first, he will be the person who will come out of that queue. Okay, so if I give you an example, so you can assume a banking line, and the first person whoever come to the particular line, he will be the first who will get out of that line. Okay, so let's see how we can do the same problem with the queue. Okay, so let's assume what we will do, we'll use two queue. So we will take q1 as this and q2 as empty. Okay, both are empty, we initialize it. Okay, so we have two, let's take an example and then I will give you that example. So first we will do, we will push the element. Okay, so we will push the 1. So let's say we will push into the q2. Okay, we push it, and now after this what we have to do, every time whenever we push it, we will do something. In pop we just remove give the top element of q or remove the top element from the q1, but whenever we pushing it, we will do a order of n operation basically, or you can say order of q2 dot length operation at the time of push. So what we will do, we will take this q, like we will pop the element from the q1 and push it to the q2 every time. Okay, so it's like q1 dot length. So now you can see q1 is empty, so there is no element, so we don't have to push anything inside this. After this what you will do, you will interchange them. Okay, so q1 become q2 and q2 become q1. Okay, so now again we have a call for push. So now the second item is second. Okay, so we have to push into the basically q2, so we'll push into q2. So now this is become q2. Now you push into the q2. Now what you have to do, you have to remove every element from q1 and push it to the q2 only. Okay, so we will pop this element and we will push it. So this will be a top element, this will always come first, then this. Okay, after this what we will do, we will again interchange them. So q2 will become q1 and this will become q2. Okay, so you got the idea why we change this, because this will be always our top. Okay, and we will always get the recent element at this position. Okay, so let's say this is 2 and we have a q1 as top as 2 1. Okay, now we have a top element, so we'll just directly give the top element from it. Now we have a pop element, we will pop it from here. Okay, so we only have one left. Now after this empty, we will check the q1 size, and q1 size is also not empty. So let's assume there are further conditions. So we need to push 3, we need to push 7. Okay, these we need to push. Okay, so first step, what we will do, we will push it into the q2. Okay, so right now q2 is empty, so we will push it. And what we will do, we will insert every element. Sorry, the element is 3, so we will insert 3. This is 3. So now after this, we will pop all the q1. So q1 will be pop it, and we will insert it here. So why we are popping it, you can see like the recent element is always come first. Why? That's why we are removing every element from one queue and inserting into the other queue. So after this, we'll again interchange. So this will become q2. q2 is generally every time it will be empty only in q1. Okay, so what we will do after this, again 7 will come, so we'll insert into q2, and we will basically pop all the element from q1. So this is having 7, then 3, then having a 1. So as you can see, this is following a stack. If I have a stack also, my 7 will be before, then 3 will be, then the 1 only. So by this, again we interchange them, and q1, and this is q2. So by this we can solve the problem. So it's pretty implementation question. So you can do, like, I have taken an order of an operation on push operation. What you can do, and my pop is order of 1, and my top and empty is also order of 1. What you can do is, instead of doing push of order n, you can do pop of order of n, and your push can be in order of 1. Either one of them you can do it. Okay, so let's write the code with this. So what we need q. So q of integer, q1, q2. Okay, we'll initialize them in the constructor. Linked list. Okay, in Java we don't have a direct implementation of q, so that's why we use the interface implementation class of linked list. Then we use q2. Okay, yeah, linked list. So let's do first pop. Okay, so what we will do, we just have to return q1 dot remove. Okay, in top, what we have to do, we just have to return top element. So q1 dot peak. Peak basically means top element. In empty, if q1 dot size is equal to 0, so we just give them. Okay, so first step is to insert new in push, basically new element in q2. Okay, then you have to, what you have to do, you have to take all the element from q1 and insert into q2. After this, you just have to swap q1 q2. Okay, so first step is pretty simple. We'll q2 dot add x. Okay, after this, what we have to do, we have to insert all the element from q1. So what we will do, while our q1 is not empty, we'll insert in the q2. So q2 dot add q1 dot remove. Okay, after doing, like, after taking all the element from q1 to q2, you just have to swap the name. Basically we are making q1 as a priority, you can say. It is more that's why we are just popping the q1 only and taking the top. So it is a main queue, you can say. So what we'll do, list basically linked list of integer temp, basically swap, we are just swapping it. So q1 equal to q2 and q2 equal to temp. I think we have done with the code, so let's run it. Okay, so there is some mistake. Okay, sorry, it will be of a type q only. Why I have taken integer? Yeah, q. Let's run it. So this is accepted. Let's submit it. Yeah, our code is submitted. Hope you like it. Thank you for watching our video, and do join the Telegram group if you're in doubt and any concern. Thank you.